In the previous video, we looked at heat and specific heat. Now that we know a little about the specific heat of a substance, we can calculate how much heat energy is required for a certain temperature change. This is essentially the equation I used to figure out how much heat energy it took to heat up the cup of water versus the gallon of water. The amount of heat energy required is equal to the specific heat multiplied by the mass, or weight in the English system, multiplied by the change in temperature. In symbols, we have Q equals C times M times delta T. In the metric system, the heat energy will be measured in kilocalories, the mass will be measured in kilograms, and the change of temperature will be measured in degrees Celsius. In the English system, the heat energy is measured in BTUs, the weight will be measured in pounds, and the change in temperature will be measured in degrees Fahrenheit. Let's take a look at how we can use the equation to calculate heat energy. How much heat energy must be added to 1,200 pounds of copper to raise its temperature from 100 degrees Fahrenheit to 450 degrees Fahrenheit? Like we saw on the last slide, Q equals C times M times delta T. The C value, or specific heat, of copper is 0.092. The mass, or weight, of copper we have is 1,200 pounds, and the change in temperature will be the hot temperature minus the cold temperature, or 450 degrees Fahrenheit minus 100 degrees Fahrenheit, or 350 degrees Fahrenheit. When we multiply this together, we see the heat energy that must be added is 38,640 BTU. In the next video, we will see how heat energy and work are related.